Hey y'all, welcome back. On tonight's homework, we are looking at circles. Specifically, we'll be finding areas and circumferences of circles, and we'll go a little bit deeper and look at areas of sectors, which are like a slice of a circle, and also arc length, which would be a portion of the circumference. So number one says,
what is the area of a circle with a radius of 32 units? Think about it.
In circle C, R equals 32 units. What is the area of circle C? So the formula for area of a circle is pi r squared. The area of a circle is pi r squared. So since the radius is 32, we can say this would be pi times 32 squared. Now, I don't expect you to do 32 squared by hand, although it's really just multiplying a two-digit number by itself. You probably could do it, but I would advise using a calculator just to make sure you get the multiplication correct, and it's 1,024, so our answer is D. Number two says,
what is the area of the shaded sector when the central angle measures 90 degrees?
So here we're looking for the area of a portion of the circle. So since the area of a circle is pi r squared, we want a certain fraction of that, or a certain percentage, however you want to think about that. And the way to figure out what fraction or percent or decimal of the overall area that you want, you're going to divide this angle measure, this central angle, which is 90 degrees, by the total number of degrees in a full circle, which is 360. So this fraction will only give you a part of the overall area. So 90 over 360 reduces, and you can do the reduction in your calculator, to 1/4, meaning that we only want 1/4 of the overall area. The radius here is 6, as given in the problem. And so we need to do 1/4 times pi times 6 squared. 6 squared is 36, and 36 times 1/4 is 9. So this is 9 pi units squared. Our answer is B. Number three says,
A cake with a radius of 12 inches is frosted on the top. If you cut out and eat a slice with a central angle of 60 degrees, what area of frosting remains on the cake?
That's so good. Here, we're not actually looking for the area of the shaded region. We're actually looking for the area that is not shaded. That shaded region is a slice of cake that we are removing. So we actually want the area of this highlighted region in red. So we'll approach it just like we did number two, but instead of using 60 degrees, we want this angle right here, which would be 360 minus 60, or 300 degrees. So the area of that red shaded region, which is the remaining frosting on the cake, would be 300 over 360, so we get that fraction of the overall area, not the full area, times the area formula pi r squared, where in this case r is 12. So 300 over 360 will reduce to 5/6, and you don't really need to do that, but I think it's kind of helpful in trying to sort of think about how much of the circle that you are actually finding the area of. We're finding 5/6 of it. So times pi, the radius here is 12, and so here we need to do 12 squared times 5/6. 12 squared is 144, and if I multiply that by 5/6, I'm going to get 120. So this is 120 pi square units. The answer here is C. Number four says,
Circle O has a circumference of 36 pi. What is the length of the radius?
6? Is that right? It sounds right.
Well, the formula for circumference is very similar to that of area, but instead of pi r squared, it's 2 pi r. If the circumference is 36 pi, we are looking for the radius, which is r. So what we need to do is solve this equation for r. we can divide both sides by 2 pi to isolate r in this equation. 36 divided by 2 is 18, and pi divided by pi is 1. So the radius is just 18 centimeters. Number 5 says a Ferris wheel
has a diameter of 42 feet. It rotates 3 times per minute. How far will I travel during a 5-minute ride?
So a Ferris wheel is basically a circle. Okay, I'm going to do just a rough sketch here of what a Ferris wheel looks like. There's little carts in here that you ride on. And so we want to know how many times, or not necessarily how many times you go around, although we will need to find that out. We want to know what distance do you actually travel as you go around the circle. So let's actually, before we start calculating that out, let's reread this problem to figure out how many times you actually go around the circle. If you rotate 3 times in 1 minute and are traveling in that Ferris wheel for 5 minutes, in each minute it rotates 3 times. So over the course of 5 minutes, you'll be rotating a total of 15 times. So 3 rotations per minute times 5 minutes will give you a total of 15 rotations. Meaning, once we figure out what the circumference of this circle is, we need to make sure to multiply that by 15 because we're going around that Ferris wheel 15 times. So the circumference is 2 pi r. In this case, since the diameter is 42, the radius is half that, so it would be 21. So this would be 2 times pi times 21, which would be 42 pi. And I'll leave it like that for now. That's how far you would go in 1 rotation. So for 15 rotations, we want to multiply that circumference by 15. 42 pi times 15. Now looking at all the answer choices, none of them are in terms of pi. So we're going to multiply that pi out in the calculator along with the 42 times 15. 42 times 15 is 630. And then if we multiply that by pi, we get approximately 1,979 feet. So our answer here is, well, looks like it's a little off here. It must have been some kind of rounding error, but the closest one is C. Number 6 says, what is the approximate
Length of
length
an arc on a circle with a radius of 3 7/8. Whoa! What the? Hey, you're everywhere. Nope, I'm out.
So we want the length of this arc right here, which will be a certain percentage or a fraction of the overall circumference. So the same strategy that we use to find sector area can be used to find arc length, where when we found the area of a sector, we just found the overall area and then multiplied it by the fraction that is being cut out. Here, same kind of thing here. We want to find the overall circumference and then multiply that by the fraction that we want. So here, the fraction will be 70 degrees, which is that central angle, out of a total of 360. This will give you the fraction that represents how much of the circle you want to find the circumference of. This should reduce, let's see, 70, 360, reduces to 7 over 36, although I don't know like how useful that particular fraction is over 70 over 360, so I'm actually just going to leave it like that. But then we need to multiply this by the circumference, which is the 2 pi r formula. All right, so 70 over 360, that does reduce to 7 over 36 if you just wanted to type it in the calculator a little bit simpler. And then we'll multiply that by 2. The answer choices are not in terms of pi, so we are going to multiply that pi out. And then the radius is 3. So we just need to be careful and make sure that we type this into the calculator correctly. I've got 7 over 36 times 2 times pi times 3. And that is approximately 3. So I'll change this equals to an an approximation here. 3.67. My kids are going to like that one. So the answer is B. Number 7. This one says,
Are you ready to rock? The figure shows a rectangle inscribed in a circle that has a diameter of 10 feet. What is the area of the shaded portion of the figure?
so here the shaded region is everything inside the circle that's not inside the rectangle. This is another example of one of those frame problems where we need to find the difference between the area of the bigger shape and the area of the smaller shape. So we'll take the area of the bigger shape, which in this case is the circle, so pi r squared, minus the area of the smaller shape, which is the rectangle. And to find that area, we're going to do length times width. So now we just need to fill in all the variables. So the radius is 5 because the diameter is 10 and the radius is half the diameter, right? What we see here is the radius, the diameter is 10, the radius is 5. So we have pi times 5 squared minus the area of the rectangle, which is 6 times 8. So just like the past few problems, none of these are in terms of pi. So we need to make sure to just multiply this out and give an approximation. So 5 squared times pi minus 6 times 8 is going to be approximately 30.5. Our answer is D. Number 8 says the circumference of a
circular disc is around 67.23 centimeters. The diameter of the disc is 21.4 centimeters. Which ratio best represents the value of pi?
Maybe I should go ahead and just sketch that out, is approximately 67.23 centimeters. The diameter of the disc is 21.24 centimeters. Which ratio best represents the value of pi? Well, the formula for circumference is 2 pi r. 2 times the radius is the diameter. So don't go through the trouble of dividing 21.4 by 2 if we're just going to multiply it back by 2 anyway. That 2 times r is the diameter, which is 21.4. So this is 21.4 pi. The circumference here is 67.23. So if we're trying to find an estimate for pi, we can divide both sides by 21.4. When I do that, I'm going to get pi is equal to, and really this is an approximation, so I really don't want to say that equals to. In fact, going back here, this is going to be approximately equal to. Even up here, this should have been an approximation because pi is going to be irrational. But pi should be approximately 67.23 over 21.4. So our answer is B. Now, you should know approximately what pi is. It's approximately 3.14. So if I divide 67.23 by 21.4, you should get about 3.14. So I want to encourage you to test that out and make sure that does equal approximately 3.14. And then, if you're kind of confused on a problem like this, just go and divide all of those answer choices and see which one's closest to 3.14. And I think you'll also find that the answer is B. Number 9 says,
Y'all want to take a walk around the fountain? You know, the one with a circular base that has a radius of 6 feet surrounded by a path that has a width of 2 feet. I wonder, what is the area of the path around the fountain?
So what we're trying to find in this problem is the area of this path. Okay, this is going to be a problem kind of similar to number 7, in which we want to find the area in between two shapes. This is another one of those frame problems. So in this problem, we need to find the area of the big shape and subtract the area of the smaller shape. So the area of the bigger shape, that big circle, will be pi r squared where the radius is 8. By the way, I'm getting 8 because the radius of this big circle is going to be the 6, which is the radius of the smaller circle, plus this extra 2 feet. So that's where I'm getting that 8 from. Minus pi times 6 squared. And now I just need to plug all of that into the calculator. So pi times 8 squared minus pi times 6 squared gives me approximately 87.96 square feet. Our answer is A. And finally, number 10. An
equilateral triangle has a perimeter of 12 feet. A circle is constructed with a diameter equal to one side of the triangle. What is the area of this circle?
Let's try to sketch this out. We have an equilateral triangle. If the perimeter of this triangle is 12 feet, and because it's equilateral, all the sides are the same, that means each side length would have to be 12 divided by 3, which is 4 feet. So we've got this equilateral triangle that's 4 feet. Now we have a circle which is constructed with a diameter equal to one side of the triangle. So we have a circle where the diameter is equal to 4, which is one side of the triangle, meaning the radius is 2. What is the area of this circle in square feet? Well, the area of a circle is pi r squared, and as I just showed, the radius of that circle is 2. 2 squared is 4, so the area of that circle should be 4 pi. Our answer is D. And that wraps up tonight's homework. Thanks for watching. As always, if you have any questions, please reach out and I'll be happy to help you. But otherwise, y'all have a great day, and I'll see you next time.